right, let's start talking about the bell work. A group of 50 runners are running a race. The top 10 get special place-specific ribbons. How many different ways can the ribbons be distributed? Does order make a difference here? Yes, so that means that this is what? A permutation, yes. Order matters. So I know on my calculator that means I'm going to choose the option that has the big capital P, but I have to type something in first. What has to go before you choose this? 50. We have our whole group first. And then you push which button on the calculator to get to the capital P? PRB. And you'll choose the option that has the capital P. And then what do we put in next? 10. This is how many places actually get ribbons. And then the calculator gives you a little bit of a confusing response, doesn't it? What looks weird on the calculator screen when you put this in?
You get a decimal.
You get a decimal, but then what's at the end of that decimal? An exponent. It's like 3.727 something something, and then it has times 10 to the 16th, right? Do you guys know what this means right here? That's scientific notation. Have you guys talked about scientific notation in science classes or math classes previously? This number is so large that it couldn't fit on the calculator screen. So the calculator moved the decimal over and told you how far it moved the decimal. To give you an idea of how large this number is, I'm going to write the full number up here. It's enormous. This is, I got to look at my notes here for this. That is how many different ways these ribbons could be distributed. Do you understand why the calculator used scientific notation with a number that large? If you get an answer back on a test question and it has scientific notation, I'm okay if you write it down using scientific notation. But I want you guys to understand the actual scope and size of that value. When your calculator is using scientific notation, if that exponent is a positive number, that means the number is so big it could not fit on the calculator screen. What do you think it would mean if it had a negative exponent? It's a very small number. They moved the decimal the other way, so it's really 0.00000 something. So very, very small if it's a negative exponent. Incredibly large if it is a positive exponent. All right. Do you guys have any questions about number one? For those of you that weren't here yesterday, we're going to practice more like number one together. On the calculators, the way you get to this is by pushing the PRB button. That gives us access to all those probability functions. Number two, identify whether each statement is true or false. If it's false, we're going to figure out what needs to be corrected so that it will be true. Part A, function A, is that the red one or the blue one on the graph? A is the red one. Function A shows exponential decay because it starts low on the y-axis. Is that true? No. This is a false statement. It does start low on the y-axis, but then what happens to it? It grows. It gets bigger and bigger and bigger. So what could I change about this statement to make it true? I could change this to exponential growth instead of decay. Part B, function B, the blue one, is a linear function because it increases at a constant rate. True or false? That is true. The constant rate that it increases at, that is the meaning of slope. That's that constant rate. The y-intercept for function A represents the number of hours worked when the income is 0. Oh, sorry, hello. He is not here today.
No, I'm right here.
The y-intercept for function A represents the number of hours worked when the income is 0. What do you guys think, true or false? The y-intercept for A represents the number of hours worked when the income is 0. This is false. Let's go look at the y-intercept. That would be right here, right? What's that ordered pair? 0, 1. And what's being represented on the x-axis? Hours worked. So this part of the ordered pair, the x part of the ordered pair, that's the hours. The y part of the ordered pair means what? That's the income, because that's what our y-axis represents. So how could I change this sentence to make it true? How could I change this sentence to make it true? Change the $0, okay? To 1. Okay. Y-intercept for A represents the number of hours worked when the income is $1. That would make this true. It's saying that the number of hours worked is how many? 0 hours worked for an income of $1. Yes. You could also change it to say it represents the income when the number of hours worked is 0. So you could have changed it that way also and still made it correct. Part D, the function rule for graph B, that's our line, is y equals x plus 1. True or false? The equation for the line is y equals x plus 1. Chris, you were shaking your head no. So you think it's false? You think it's true? Chris says it's false. Let's look at it. How do we write equations for lines? What's slope-intercept form? Y equals mx plus b. What does b represent? The y-intercept. Where is the blue line intersecting the y-axis? At 0, 0. Here's the y-intercept here. So what should be right here? A 0. What do they have in the equation? They have a plus 1. Should it be plus 1? No, that should be plus what? Plus 0. Or you could just leave it blank if it's plus 0. Yeah. It does have a slope of 1. It is going up 1 and right 1. So our slope, our rise over run, is correct. Because in front of the x there is an invisible 1. So this was false the way it was written. Last one. The function rule for graph A is y equals 1 times 2 to the power of x. True or false? Y equals 1 times 2 to the power of x. True or false? This one is true. All right. We're going to go to page 151. We're going to do some more practice with combinations and permutations today. We're going to do the first two together, and then I'm going to give you guys some independent time to look at the rest of the examples on this page. Page 151, dear. Zero. Page 151. First thing we want to determine about both of these is, does the order make a difference? Will the things being selected all be treated the same? If they're all going to be treated the same after they get selected, order doesn't matter. If they're going to have different responsibilities or they're going to be treated differently, then the order matters. Then we would say it's a permutation. When order matters, it's a permutation. When order doesn't matter, it's a combination. So I'm looking at number 9, page 251. We have a group of how many students? 13 total students. And we're going to choose how many of them? 5 of them. And what are those 5 going to do? They're going to ride in a car. So let's imagine for just a minute that I pick you 5 right here. As I'm reading out the names, does it matter whether I call Dalen's name first or Greg's name first? So what would we say this is? Yep, this is a combination, yes. That's okay. This is a combination. Order does not matter. The 5 selected students will all be treated the same. Okay, so I know it's a combination, so that's a big capital C. What do I have to type in first before I choose that option, though? 13. 13 is the whole group that we're choosing from. So you type 13 in on the calculator, and then you push what button? PRB, and then you choose the NCR option, the one with the capital C. And then after you choose that, what number do we push? 5. This is how many will actually be selected. How many different ways can this happen?
1,000.
Yes, 1,287 different ways that these students can be selected. All right. Number 10, selecting which 6 players will be in the batting order for an 11-person team. So we talked a little bit about this yesterday. I'm only so-so on baseball, but I'm thinking the coach sitting down in his living room, coming up with the batting order ahead of time. Would he want to put his home run hitter first up to bat? Probably not. He's probably going to want to have those bases loaded and then bring the home run hitter up, right? So does order make a difference here? Yes, which means this is what kind of situation? Permutation. All right, so I know this means the capital P when I get there, but before I choose that NPR option, what do I need to type in first? 11. We have our whole group. Then you push the PRB button for probability. How many people actually get to bat? 6. So if Coach were going to sit down and write down every possible way he could put together this batting order, how many different ways could he do that? Yes, 332,640 unique batting orders. If he decides to write down every possible way of putting together the batting order, he's going to be doing this for a while. All right. I want to give you guys about 10 minutes to work on the remainder of the page. Start off by deciding, is it a combination or is it a permutation? Does order make a difference? Will they all be treated the same so order doesn't matter? Will they have different responsibilities or be treated differently so that order does matter? There's a couple of these that we could kind of argue about that you have to understand some of the context. So if I disagree with you when we're talking about it, let's go back and forth a little bit, okay? But I want to give you guys about 10 minutes to work on this independently before we go through it together. Compare notes with your neighbors too. All right. So there's some of these where context really matters and your knowledge of the situation really, really matters. I think number 11 is a great example of this. I only know so much about basketball. My kids only played when they were little and on rec teams. I've never had like a high school basketball player in my home. And I don't follow sports too much. So when I'm thinking about selecting the starters, those of you that know a little bit more about sports than I do, at the high school level, at the college level, at the professional level, does the order of selection for the starters matter? Yeah. So if we're talking high school, college, professional, you said order of selection of the starters makes a difference. So we would say that's a permutation. What number do I need before the P? 9. After the P? 5. So if order makes a difference, because I agree at this level it probably does, how many different ways can those 5 starters be chosen? 15,120 different ways we could name the starters. Now, in my experience, with my kids on a little rec team, does the order matter when we're talking about little kids playing recreationally? If coach is trying to pick out which 5 kids start that day? Order doesn't matter as much then. So if I was going to set this up, if my understanding of it was talking about little kids rec team, would I still consider this a permutation? No. Then it would be a combination. So I'm thinking I've seen some coaches with groups of 5 and 6 and 7-year-olds that are about yay big. And they get told, you 5 right there, you guys are going out and starting. You 4, you're on the bench until I send you in to sub in. How many different ways could the coach decide if the order doesn't matter? $126. A lot fewer options. If the order doesn't make a difference, we have a lot fewer options here. All right. Number 12, talking about handshakes. if you're in a room of 110 people, and this is obviously written pre-COVID because I don't know a lot of people that are going around shaking 110 hands right now. But if you're going to end up shaking hands with everybody in the room, does the order that you shake hands with those people make a difference?
No.
No. So this would be a combination. We have 110 people in the room, but for each handshake that takes place, how many people are involved in that handshake? Just two. No, you're fine. Just two at a time. And every time a handshake happens, how many people are involved in that handshake? That's how many total handshakes will take place, yes. But every time a handshake happens, how many people are involved? Two. You said 5,995 total handshakes will happen in that room. That's a lot of handshakes. All right. I like this next one too. Do you guys remember when we were learning about and or, intersections and unions? And we had to talk about the difference between the way we use certain words in everyday language and the math definitions of things. That and was very exclusive, that you had to belong to both groups in order to be included, and that the or was very inclusive. As long as you fit into one of these groups or both of these groups, or everybody's welcome. And that's not necessarily the way we use those two words in our everyday speech. This is another example of that. When you talk about your locker combination, I want you to think about going and opening your locker. Even if you don't use it, I'm assuming at some point you've opened one before, right? Does the order that you enter the numbers in make a difference?
Yes.
Yes. Now, do you think when the school is setting up those different locker combinations, they care what number or what order the numbers are in? They couldn't care less when they are setting those. When they're doing that in Skyward and they're setting those systems up, they don't care about the order that it's in. But when it comes to actually opening it, the order definitely makes a difference. You can know those three numbers, but unless you put them in the right order, that locker's not opening. Same situation here. We call it a locker combination, but because the order matters, this is actually an example of what? This is actually an example of a permutation. You might not care when you're setting it up what order it's in, just like the school doesn't really care when they're making all these codes up. But when it comes to actually using that, order makes a difference. Okay, how many numbers are you considering on this lock? Yep, you are considering 3 different numbers. What are the 3 numbers that you're considering? 1, 2, and 3. Those are the only numbers that you want to use. You want to keep it simple. You're going to end up choosing how many of those numbers? All 3 of them. So since you're setting this 3-digit lock and you're going to use all 3 of those numbers, once you choose to use the 3, you're not going to use it again, right? So this would be the same as 3 factorial. Because once you use a number, you're not going to reuse the same number. It didn't say anything in here about us having a combination that's 333 or 111. We want to use all 3 of these digits. How many different ways could you choose to do this? 6. There are 6 unique lock codes. I know we usually call them combinations, but when I'm talking about them in here to try to keep it very clear of whether I'm talking about a permutation or a combination, I tend to call them codes when we're talking about locks instead of combinations, just so we don't get confused between the everyday language and the mathematical language. All right, number 14. This one might be a little bit more difficult. Most of the time when we talk about a race, is it a combination or a permutation? Permutation. Order makes a difference, right? Here, we have qualifications happening. They didn't use that word, but what did they describe happening here? Eight are going to be the finalists. They're going to advance on to the finals, right? Are those 8 people that advance, is that just, if you came in first, you get first place in the finals? No, you still have to go run another race, right? If you get 8th place in this qualifying race, does that mean that there's no way you can get first? No. So if you're having an off day, but it's qualifications day, you only care what? You just want to be in the top 8. You really don't care if you're 1st or 5th or 8th. As long as you make that top 8 cutoff, you're going to move on. So does it matter if you're 1st versus 5th?
No.
So does that make this a combination or a permutation? This is a combination situation. What'd you say?
It should be per, because it matters getting the 8th spot or 7, the top 8.
If you're in the top 8, you move on. So we're looking at all the different ways the top 8, that group could be made. Whoever came in first, they're going to advance. If that same person were to come in 7th, they're still going to advance.
Let's say the person that made to the 9th spot, they don't feel sad or something.
You said the 9th spot?
Yeah, they don't feel sad, they don't feel away, so it doesn't matter.
Whether they're in that top 8 group or not matters, yes.
Okay.
But coming in 9th versus coming in 25th, you're not moving on. So really what they're doing here is they're not handing out places necessarily. They're putting you into 2 groups. This group is going to move forward. This group is not going to move forward. Does that make more sense? Yeah. So yes, there is a difference between finishing 8th and finishing 9th, but it just determines which group you're going to belong to. So we have a combination here. 25 people. 8 get to move on. How many different ways could these top 8 finishers be chosen? How many different ways could the top 8 finishers be chosen? Can you guys give me the first number that showed up on your screen? Yep. So I got 1, 0. What's the next digit? 8, 1, 5, 7, 5. Yes. There are more than 1 million different ways that this could turn out. Just setting up these 2 groups. You move on, you don't move on. All right. Let's look at number 15. When we're trying to decide between a combination and a permutation, we're trying to figure out, does order matter, does order not matter? Order matters in situations where the people selected will be treated differently. Order does not matter if they're going to all be treated the same. If they're going to pick out a president, vice president, and treasurer, will those 3 people have the exact same job responsibilities? So combination or permutation? Permutation. So I have 35P, and we're going to pick 3. How many different ways can this group of people select their president, vice president, and treasurer? 39,270. What about the one below it? Combination or permutation? Permutation. Why permutation? They all have different jobs. They have different responsibilities. This would be 32,760. What about players to carry the water cooler? That's a combination. Doesn't matter. You guys are just going to all go help carry the cooler. What about choosing roses? Does it matter if I pick out the yellow roses before the pink ones? Or the pink ones before the yellow ones? As long as they end up in this bouquet that I'm going to give, that's all I care. So there's the group that I'm selecting and the group that I'm leaving out. This is a combination. Have a great rest of your day, guys. I'll see you tomorrow. Don't forget you have homework due tomorrow.
What was the test out of?
The test?
Yeah, because like you just put the number at the top. Is it like out of certain points or 100?
Oh, you're talking about the review. The review was
Oh,
out
that
of...
was the review?
Yeah, that was the
Okay.
review. It's out of 40.
Okay, thank you.
You're welcome.